So go to module 3, question 5. Question 5 says, let f be a function defined as f of x is sine ax over x. Right, so f of x is equal to sine ax. F of x is sine ax. Sine ax over x. And f of x is also 4. F of x is sine ax over x. This is when x is not equal to 0, of course. And it's equal to 4 otherwise. And this is if x is equal to 0. And they said now, find the value of a if the function is continuous. If the function is continuous, all right, so what we can write is, since f is continuous, then since f is continuous, then we know that f of 0 is equal to 4. Yep, f of 0 is equal to 4. All right, and the left-hand limit is equal to the right-hand limit. All right, the part that we're really going to utilize is the fact that the left-hand limit is equal to the right-hand limit. So what does that mean? That means we're going to utilize the fact that the limit as x approaches 0 of sine ax over x, this limit is equal to the limit as x approaches 0. It's equal to the limit as x approaches 0 of 4. Now, the limit as x approaches 0 of 4 is just 4. All right. Now, look what we're going to do now. Over here now, this side, we have the limit of sine ax over x. Now, we know that the limit of sine x over x as x approaches 0 is 1. So what we're gonna do is multiply. We're gonna put an a down here. But if we put an a down here, we have to put an a up here. All right, we have to put an a down here. Now put an a here. We're multiplying by a over a. That makes sense? Yes. Then look how we're gonna write this now. Now we're gonna write this as the limit as x approaches 0 of a times, in bracket, sine ax over ax. Sine ax over ax. Now the limit as x approaches 0 of sine ax over ax is 1. All right. Now, according to limit laws, the limit of a product is equal to the product of the limits. So we can rewrite this as the limit as x approaches 0 of a multiplied by the limit as x approaches 0 multiplied by the limit as x approaches 0 of sine ax over ax. Nice and easy, soft. So this is what we have. The limit as x approaches 0 of sine ax over ax. This is equal to 4. Now the limit of sine ax over ax, this part is 1. And the limit as x approaches 0 of a is a. So what we're getting is a times 1 is equal to 4. And since a times 1 is equal to 4, this implies that a equals 4. All right, nice and easy. So a equals 4. Soft. no issues. The next part of the question, it says that using first principles, determine the derivative of f of x, which is equal to sine 2x. Determine the derivative of f of x, which is sine 2x. All right, so f of x is equal to sine 2x. All right, now to find the derivative from first principle, we have to remember that f prime of x, using first principle, f prime of x is equal to the limit, it's equal to the limit as h tends to 0 of f of x plus h is equal to f of x plus h minus f of x over h. That's how we find the first derivative. All right, so let's plug in this now. So it's going to be equal to the limit as h tends to 0. It's the limit as h tends to 0 of, we can go ahead and put sine. So it's the limit now, f of x plus h is going to be the sine of, you're replacing x with h, so it's going to be 2x plus 2h, or you can write it as the sine of 2 times x plus h, 2 times the sine of x plus h, minus the sine of 2x over h. Right? So that's what we're going to do. So let's break that up now. That is equal to now the limit as h tends to 0 of. Now there are two ways I can do this. Now this sine of 2x plus h, all right, I am going to rewrite this right here as sine 2x plus 2h. This is really the sine of 2x plus 2h when you expand in the 2. Now using the compound angle for that, we know that the compound angle is sine 2x cos 2h, sine 2x cos 2h plus cos 2x sine 2h plus cos 2x sine 2h sine 2h minus sine 2x, and this is all over h. Everything is all over h. So what do you do next? Now one thing I notice is that this right here, we have sine 2x right here, and we have sine 2x right here. So we can group those two, and we can factorize sine 2x from those two. So this is going to be equal to the limit as h approaches 0 of, I'm going to group these two and factorize out sine 2x. If I factorize sine 2x, I am left back with, in the bracket, that's going to be cos 2h. And then when I factor out sine 2x from this right here, I get minus 1. All right. And instead of writing everything over h, I'm going to divide this side specifically by h and write plus the limit as h approaches 0 plus the limit as h approaches 0 of cosine 2x sine 2h over h. All right. Nice. Now using laws of limits, the limit of their product is the product of their limit. And so what I'm going to do is right here, so I have a cos 2h here, and so I need a 2h in the denominator. So I'm going to put a 2 right here and put a 2 up here. All right, I need a 2 in the denominator, so I'm going to put a 2 right here and a 2 up here just to make it balance. Then using limit laws, all of this work out to be equal to, it's going to be the limit as h approaches 0 of, it can be written now as limit as h approaches 0 of 2 sine 2x, limit as h approaches 0 of 2 sine 2x multiplied by, limit of the product is the product of their limits multiplied by the limit as h approaches 0 of, I separated them now as two different products, and so now this is just cos 2h minus 1 over 8 over 2h. But remember, the limit of cos theta minus 1 over theta is 0, right? Plus the limit as h tends to 0, separating them as the limit of the product now, that is now 2 cos 2x plus limit of 2 cos 2x over 1 times the limit as h tends to 0 of sine 2h over 2h. This is now sine 2h over 2h. Sine 2h over 2h. All right, that's what we have. Now that this is what we have, this is now equal to, plugging in h as 0, now the limit as h approaches 0 of this is just 2 sine 2x. This is just 2 sine 2x. But then plugging in h as 0 here, you get times 0. That becomes times 0 plus, when you plug in now h as 0 here, you're going to get 2 cos 2x. 2 cos 2x times the limit as h approaches 0 of sine 2h over 2h is 1. And so the final answer is anything times 0 is 0. So the final answer is 2 cos 2x. So the final answer is 2 cos 2x. Nice. So we can put it up here. That is f prime of x is equal to 2 cos 2x. Nice and easy, soft. This question, soft, that capital T. Now let's move on to part C. Alright, so part C, as it is saying, it says that y is equal to 2x over the square root of 1 plus x squared. Now this question, I am going to use implicit differentiation to do this. Anytime I see square root, implicit come to my mind. Anytime I see square root, honestly. If you don't know implicit differentiation, click the link in the description and watch that video on implicit differentiation. So to do implicit differentiation, first thing we're going to do is square both sides. So we're going to get y squared is equal to, y squared is equal to, when I square both sides, I'm getting the numerator, when I square it, is 4x squared over the denominator is 1 plus x squared. Now doing implicit differentiation is easy for me to differentiate this now. Doing implicit, I can differentiate this now to carry down the power to get 2y times dy by dx. That's implicit differentiation. So that becomes 2y dy by dx is equal to, start with the bottom, which is 1 plus x squared, times the differential of the top. The differential of the top is, that looks like 8x minus the top, which is minus 4x squared, times the differential of the bottom. The differential of the bottom is 2x over the bottom square, and the bottom square is 1 plus x squared. Nice, this is 1 plus x squared. Okay, 1 plus x squared all square. Now I'm going to expand out the numerator. Expanding out the numerator, I get 1 times 8x is 8x plus 8x times x squared is 8x cubed. And then I have 4x squared times 2x, that's also 8x cubed. So notice that the 8x cubed, them cancel each other. All right, and now I'm just dividing by 1 plus x squared all square. So the differentiation part done already. All we're doing is just testing our algebraic skills now. Differentiating part done is just algebraic skills. So this implies now we have 2y dy by dx, 2y dy by dx. We have 2 dy by dx is equal to, we have that this is equal to 8x plus 8x cubed minus 8x cubed. So that is just 8x over 1 plus x squared all square. 1 plus x squared all square. All right, nice. Now, next thing we're going to do is divide through by 2. Dividing through by the 2y, we're going to get dy by dx. So we're going to get dy by dx is equal to, when we divide through by 2, this becomes 4x over, we divide through by 2y now, you know. So this becomes 1 plus x squared square, 1 plus x squared all square times y. All right. But remember the question wanted x dy by dx, don't it? It wants x dy by dx. So to get x dy by dx, we need to multiply both sides by x. So let's multiply both sides by x. So what that is giving us then is x dy by dx is going to be equal to, multiplying both sides by x, we're getting 4x squared over 1 plus x squared, 4x squared over 1 plus x squared all square times y. But now look at this now. Look at this. Remember 4x squared, I can break up 4x squared as, 4x squared can be broken up as 2x times 2x, times 2x squared, don't it? I can break up the numerator as 2x times 2x. Then in the denominator, I can break up 1 plus x squared as the square root. I can break up 1 plus x squared as the square root of 1 plus x. This can be written as the square root of 1 plus x times the square root of 1 plus x times 1 plus x squared. This is the square root of 1 plus x times the square root of 1 plus x times 1 plus x squared. And it is still being multiplied by y. I can break up the denominator like that. All right, nice. Okay, good. Now look at this now. What is 2x over, what is 2x over the square root of 1 plus x? But look at this, we don't even have to write the numerator as 2x squared. We don't even have to write it like that. We can write the numerator as 2x times 2x times x. Yeah, man, times x. Because guess what? Look at that now, 2x. As we can see, this part right here, wait, 4x squared, yeah, 4x squared is 2x times x, my apologies. 4x squared is 2x times 2x. Now what am I saying now? I am saying that this 2x over the square root of 1 plus x, this part is y. This is y, and this 2x, that is y, and this 2x over the square root of 1 plus x is also y. This part is also y. Nice. And so what we're getting is that this answer is working out to be y times y is y squared. So I'm getting y squared over 1 plus x squared times y. 1 plus x squared times y. So that is x dy by dx. So to finish it off, we have that x dy by dx, x dy by dx, x dy by dx is equal to, we have y squared over 1 plus x squared times y. We can then divide, we can see that the y square, this y square, you can break up y square as y times y in the numerator. And if you break it up as y times y, this y cancels this y. And so finally we can conclude that x dy by dx, x dy by dx is equal to y over 1 plus x squared. So again, just use implicit differentiation and it works out so easy. I highly recommend learning implicit differentiation. I know a lot of teachers do not teach implicit differentiation at the Unit 1 level. So I highly recommend you learn it, and you should. If you don't know implicit, check out the link in the description to watch implicit differentiation. Now let's look at part 2. Part 2 of the question, it says, show that d2y by dx squared plus 3y over 1 plus x squared all squared is equal to 0. So to show part 2, right? Oh, make sure you put that you show it now. So proven, all right? So it's proven, all right? Okay, so for part 2, it's a second derivative question. What I ideally, anytime I prove something, I like to start with that. So I just proved that x dy by dx, x dy by dx is equal to y over 1 plus x squared. All right? X dy by dx is y over 1 plus x squared. So I'm going to start with that. X dy by dx is y over 1 plus x squared. So if I divide both sides by x, if I were to divide both sides by x, in reality, dy by dx is really equal to y over 1 plus x, y, dy by dx is y over 1 plus x squared times x. All right, that's dy by dx. So now from this, I can go ahead and find the second derivative. The second derivative, I'm going to use quotient rule. So d2y by dx squared is equal to, start with the bottom. So the bottom is 1 plus x squared times x. In reality, that is x plus x cubed. So it start with the bottom times the differential of the top. When you differentiate y, you get dy by dx. And we already know what dy by dx is. It's in this line, minus the top, which is y, times the differential of the bottom. When you differentiate the bottom, you are differentiating x plus x cubed. When you differentiate x, you get 1. When you differentiate x cubed, you get 3x squared. And this is all over the bottom square. I don't like this line. Let me fix it better. All over the bottom square. When I'm squaring 1 plus x squared, what I'm going to get is 1 plus x squared square. So I get 1 plus x squared square times x squared. That's what I get when I square the denominator. So this is d2y by dx squared. So going around here, what I get is d2y by dx squared, d2y by dx squared is equal to, now that I have this, x plus x cubed dy by dx minus y times 1 plus 3x squared over this, I can go ahead now and simplify this. Let's go ahead and simplify this. I notice that this part, I can separate them as two separate fractions. Yes, I'm going to separate it as two separate fractions. I'm going to write it as x plus x cubed dy by dx. And instead of writing x plus x cubed, I'm going to write it as x into 1 plus x squared times dy by dx. And this is all being divided by all of this is being divided by 1 plus x squared over x squared. I don't need to separate them yet. Let's just continue writing it out. So x times 1 plus x squared minus, I'm going to expand in with the y now. Expanding the y, it's going to be minus y minus 3x squared y. So it's minus y minus 3x squared y minus 3x squared y over, this is over 1 plus x squared, 1 plus x squared, all square times x squared. All right, now let's look at how we can simplify this now. We want to simplify this, and as I can see, remember we said that what is dy by dx? What is dy by dx? We're going to substitute for dy by dx right now, and everything else will work out. Remember we just said that dy by dx, going around here, this is dy by dx, y over 1 plus x squared times x. So I'm going to plug in that in here for dy by dx. So I'm going to make a big substitution, so pay close attention. So it's x times 1 plus x squared, and we had said that dy by dx is equal to, again, let's go back, look at it. It's y over 1 plus x squared times x. So dy by dx is y over 1 plus x squared, 1 plus x squared times x. That's dy by dx minus y minus 3x squared y over 1 plus x squared times x squared over 1 plus x squared all square times x squared. Right? Now what you get now is this 1 plus x squared cancels the 1 plus x squared. This x cancels the x here. Ah, nice. So all of this is just working out now to just be, this in the numerator works out to just be y minus y that gone. So it's just working out to be y minus y minus 3x squared y minus 3x squared y over 1 plus x squared all square times x squared. Right now it just gets so basic, it's so boring now. All right, so now it gets so basic that all we're getting now is d2y by dx squared. It's just equal to d2y by dx squared is equal to y minus y cancel, so you get minus 3x squared y minus 3x squared y over 1 plus x squared 1 plus x squared all square times x squared. Now, as you realize now, this x squared cancels this x squared in the numerator. And so what are we left back with? What we're left back with is minus 3y over 1 plus x squared all square. So now that this is what we get, we can just bring it over to the other side to get this implies now, adding this to the other side, we're going to get d2y by dx squared plus 3y over 1 plus x squared all square. This is equal to 0. This is shown. Nice and easy, soft. This is shown. Nice. All right, so that is shown. Nice and easy, soft. All right, so this takes care of question 5. And now we reach the penultimate question of the paper. Penultimate means second to last. So we reach the final question of the paper, which is question 6. All right. Now question 6 says the diagram below shows a region bounded by the lines y equals 3 minus x, y plus x equal 9, and 3y is equal to x plus 3. Now before I even do this question, I noticed that I have equations of lines, and I just like when all of them in standard form. That's me. It really annoys me when they're not in standard form, and I'm going to perform simultaneous equations. So y is 3x minus 7. The other one, if I make y the subject, the one that says x plus y is 9. From that one, it is telling me then that y is equal to, that looks like 9 minus x. And the final one that tells us that 3y is equal to x plus 3. I'm going to rewrite it as y is equal to 1 over 3 times x. So it's 1 over 3 times x. All I do is dividing through by 3 plus 1. So I put all of them in standard form. Makes it easier. It makes it easier. 1 over 3 times x plus 1. It makes it easier for us to can do other computations with these lines. Now let's hear what they say. They say show that the coordinates of A, B, and C are 4, 5, 3, 2, and 6, 3 respectively. So I'm going to draw a schematic of the curves. You have this. I'm going to draw the lines in red. So you have the line 3x minus 7. That's a gradient of positive 3. Gradient of positive 3 and cuts the y-axis at minus 7. So this can be something that resembles that. All right, so that's the line that we have. This is minus 7. All right, with a gradient of positive 3. Then we have the line y equal 9 minus x. Let's put that in another color. 9 minus x pass through positive 9 with a gradient of negative 1. That looks something like this. All right. Gradient of negative 1. So that looks something like this. Let me put that this is the point positive 9. So let me label them as L1, L2, L3. This is L1, this is L2, and then I need L3. L3 is going to be L3, as you can see, L3 is 1/3 x plus 1. So it cuts the y-axis at +1. Cuts the y-axis at +1. So L3 looks something like, and it has a gradient of 1/3. All right, so it cuts the y-axis at +1. All right, so this can represent, no, let me make it a little better. This can represent L3, all right? This can represent L3, and this is y-axis intercept +1. All right, I just like to put it on a graph. It makes it easy for me to see what's going on. So this is L3, all right? So now the intersect, the 3 points of intersection are here, here, and here, all right? And they want us to show that the coordinates A, B, and C are those respectively. So to do that, the first thing we can realize is that A is the intersection between L1 and L2. So write that down. So A is the intersection of L1 and L2. All right, so we're going to solve those two lines simultaneously to find the coordinates of A. So solving them simultaneously, as we can see, A being the intersection of L1 and L2, we have y is 3x. So we have y is equal to L1 is 3x minus 7. And then the next one is x plus y. So it's going to be x plus, what is y? Y is 9 minus. Y is 3x minus 7. All right, we substitute it into the second one, that's equal to 9. All right, and so what that implies then is that we're getting 4x. We're getting 4x minus 7 is equal to 9. And so that is telling us that 4x is equal to 16. And so that is then telling us that, so x equals 4. If x is equal to 4, we plug it in y, and so y is going to be equal to 3 times 4 minus 7. So 3 times 4 minus 7, that will give us y. And what is 3 times 4 minus 7? When you work that out, what we're getting is 3 times 4 minus 7. 3 times 4 minus 7, that works out to be 3 times 4 minus 7 is 5. Is that the point A? A is 4, 5. Let's check it. Yes, we get it. And so A is the point 4, 5. A is the point 4, 5. Now that we get the point A, next thing we need now is to find the point B. Now B is the intersection of L1 and L3. So B is the intersection of L1 and L3. That is B. B is the intersection of L1 and L3. So now what is L1? L1 is the equation y is equal to 3x minus 7. That is L1. All right. And L3 is the equation 3y. L1 and L3. L3 is 3y plus 3y is equal to x plus 3. And then remember, y is 3x minus 7. So substitute it here, 3x minus 7. Solving this equation, what we're going to get is 3 times 3x is 9x minus 3 times 7, that's 21. That's equal to x plus 3. Bringing x over there, so we're getting 8x is equal to 21 plus 3 is 24. Dividing both sides by 8, and so x is equal to 3. Since x is equal to 3, y is going to be equal to 3 times 3 minus 5. And so y works out to be 9 minus 5 is 4. Is that right? All right, so did we make any mistake? Because 3 times 3 is 9, 9 minus 5 is 4, but it shouldn't be 4. Let's look. Oh, my apologies, it should be 7. And so that becomes 2. And so now we get B is the point. So B is the point. B is the point that is, what we got for x again? 3 and 2. Finally, we have now C. C is the intersection. C is the intersection of, C is the intersection of, that looks like L3. C is the intersection of L3 and L2. All right, and what we had for L2, L2 was x plus y, or we had write it as y is equal to 9 minus x. And then L3 was 3y, and so it's going to be 3 times y, which is 9 minus x. That's equal to x plus 3. So we can go ahead and solve this now. And we're going to get 27 minus 3x is equal to x plus 3. And so we're going to get that. So we're getting that. Bring over the 3x over here, we get 4x. Bring over the 3x over here, we get 4x. Bring over the 3 over here, we get 27 minus 3. 27 minus 3 is 24. And so x is equal to 6. If x is equal to 6, y is going to be equal to, x is 6. 9 minus 6 is 3. And so C is the point. X is 6, y is 3. And so all of those are shown. Nice and easy, soft. Shown. All right, nice. So now we've shown all of this, all right? All of these are shown. Now we need to go ahead now and we need to find, use integration, determine the area bounded by the curve. Well, I wouldn't want to say curve, the area bounded by the lines. Now the area bounded by the lines is a triangle here. So it's the area of the triangle we're ultimately finding. So the area of the triangle we're finding is in here. All right. So the area in here. So the area in here is going to be, remember, we'll find area, it's going to be the integral of this line from this point to this point plus the area of this line from this point to this point minus the area below this line. Ah, I see it. Nice. So we're going to integrate from this point to this point of this line. So let me write it down here. We're going to call it area A. So this is part 2. So the area A is going to equal to the integral of this line. This line is L1. So we're integrating L1 from B to A. So we're integrating from B was the point, I think that was X point was 3. So integrating from 3 to 4. Integrating from 3 to 4 of L1 plus we're then going to integrate We're going to integrate then from A to C. From A to C is 4, 6. And which line are we integrating from 4 to 6? We're integrating L2 minus, then now we need to subtract the integral of this line now, which is minus the integral of L3, and we're minusing the integral of L3 from B to C, which is from 3 to 6. All right, so we're subtracting that integral. All right, minus the integral from 3 to 6 of BC, and that BC line was L3. So let's work this out now. So the area is equal to the integral from 0 to 4 of L1. Remember we had found L1. L1 was 3x minus 7. So we're integrating 3x minus 7. That's why it's good to have the graph. It makes it a lot easier. So it's 3x minus 7 dx plus the integral from 4 to 6 of L2, and L2, we put it as 9 minus x, that's why 9 minus x, minus the integral of L3, which is from 3 to 6 of 1 over 3x plus 1, 1 over 3x plus 1. I left off my dx, but don't kill me. So now we're going to integrate them, and so the area that we're getting is equal to 3x integrated minus 7. I'm going to get 3x squared over 2. So I'm going to get 3x squared over 2 minus 7x. And remember, when we integrate, we're integrating from, that was from 3 to 4, plus we're then integrating L2. When we integrated L2, we're going to get 9x minus x squared over 2. That's plus 9x minus x squared over 2. And we're integrating from 4 to 6. Integrating from 4 to 6. And then what we're getting is minus the integral from 3 to 6 minus the integral from 3 to 6 of 1 over 3x plus 1. So integrating 1 over 3x plus 1, integrate that, we're going to get 1 over 3x squared, and divide that by 2, it becomes 1 over 6. All right, 1 over 6. Just making sure again, integrating 1 over 3x, it becomes x squared divided by 2x squared over 6. This becomes x squared over 6. And then plus 1, you integrate plus 1, you get x. And we're integrating from 3 to 6. So now you just time to use up your calculators, and that will give you the area. So the area of the triangle, when I put in 4 in my calculator, I'm going to work it out. 3 times 4 squared divided by 2 minus 7 times 4. When I put in 4, I'm getting negative 4. Then I put in 3 now minus. When I put in 3, I get 3 times 3 squared divided by 2 minus 7 times 3. I get minus 7.5, so I get minus 7.5 plus, now I need to put in this now, which is 6 and 4. When I put in 6, I get 9 times 6 minus 6 squared divided by 2. I get 36 to be the answer. Then I put in 4. I'm going to get 9 times 4 minus 4 squared is 16 divided by 2. I get minus 28. 36 minus 28 minus, I put in 6 now. Put in 6 square. 6 square is 36 over 6, which is 6 plus 6, which is 12. And I put in 3. 3 square is 9. And I get 9 over 6 is 1.5 plus 3, which is 9.5. So I subtract 9.5. Okay, almost finished. So now I put all of this in my calculator. Minus 4 minus 7.5. This part is 3.5. Plus this part is 36 minus 28, that's 8. I'm positive. Minus 12 minus 9.5. 12 minus 9.5 is 2.5. We're getting is 3.5 plus 8 minus 2.5. I'm getting 9. All right. Now, anytime you get an answer, you just want to check to make sure you are integrating properly. 9 minus 3x squared over 2 minus 7x. 9x over x squared over 2. X squared over 6 plus x. So all of these are integrated properly. Just want to check again. 4 here is 12. 12 times 3, 36. 36 over 2, 18. 4 here is 28. 3 times 4 squared divided by 2 minus 7 times 4. That's minus 4. This is fine. Just checking back over one final check, because sometimes we make calculation error. 3 times 3 squared divided by 2 minus 7 times 3 minus 7.5. So this is good. Over here now, 9 times 6. 54 minus 6 squared. 6 squared is 36. 36 over 2. That's 36. Put in 4. 9 times 4. 9 times 4 is 9 times 4 is 36. Put in 4 in here. 4 squared. 4 squared is 16. 16 over 2 is 8. So 28 is fine. Minus. Put in 6. 6 squared. Divide by 6 is 6. Plus 6 is 12. 3 squared. Divide by 6. Plus 3. Okay, I see the mistake now. This shouldn't have been 9.5. This should have been 4.5. See how easy we made a mistake? That's 4.5. So when I subtract these two, it's 12 minus 4.5. 12 minus 4.5 is 12 minus 4.5 is 7.5. So the answer is 4. And you might have wondered why I was checking so rigidly for this answer. That's because looking at the triangle area don't look like it was so much. How do I know? I'm going to test it. I really wanted to show you all this method. All right. I don't know if you all remember from CSEC. From CSEC, there's formula. There's always a formula sheet for area, right? So remember, we're trying to find this area in here, the area shaded, which is the area of this triangle, right? There's a formula that's always been on the CSEC paper that a lot of people, they never even utilize ever. There's a formula that tells you that area A is equal to the square root of S times S minus A times S plus A, S minus A times S plus A, S minus A times S minus B times S minus C. This formula is on the C-Sec paper, and we never ever utilize it. So I'm going to utilize it now to show you that the area of the triangle is indeed 4. All right, always remember this formula. Well, you don't have to, but I like you to. So A is the length of AB, so this is A. BC is the length B, and this is C. So we need to find these three lengths, A, B, and C. So finding these three lengths, that means we need to find the length AB. The length AB would be equal to, remember it's x1 minus x2 squared. We already know B and we know A. Remember A is the 0.45 and B is the 0.32. So if you were to find the length of the line AB, it's going to be the square root of x1 minus x2 squared. So it's 4 minus 3 is 1 plus 5 minus 2 squared is 3 squared, which is 9. And so AB is the length, the square root of 10. All right, so that's AB. Let's find the length AC. The length AC will be equal to, the length AC is equal to, C is the 0.63, so it's equal to 6 minus 4 is 2, so 2 squared is 4, that's the square root of 4, plus 5 minus 3 is 2, 2 squared is 4, and so AC is the square root of 8, and then we need to find the length from B to C, which is 6 minus 3 is 3, so 3 squared is 9, 3 minus 2 is 1, 1 squared is 1, so the length BC is also the square root of 10. And you might wonder, so sir, where are you going with this? Now look where I'm going with this. Going to C-Set Maths, all right? Now when you remember S is equal to A plus B plus C divided by 2. I know some of you would probably never use this formula. And so in this case, S is equal to root 10 plus root 10, which is 2 root 10 plus root 8 plus root 8 over 2. That is S. Now root 8 is 2 root 2, and so we can rewrite this as S is equal to 2 root 10 plus 2 root 2, because root 8 is 2 root 2 over 2. And when you do the division, you're going to get that S is just root 10 plus root 2. That is S, root 10 plus root 2. So you might say, sir, why is this important? Look why it is important. It's good when you can do your questions in multiple ways. So the area is going to be the square root of S. S, which we just see, is root 10 times root 2. Root 10 plus root 2. Root 10 plus root 2 times S minus A. S minus A is going to be root 10 plus root 2 minus root 10. Remember, A was root 10. A is what we call AB. The distance AB, we call that A. So it's root 10 plus root 2 minus root 10. So just leave it back with root 2 for S minus A. S minus B, also just leave it with root 2 because B was root 10. And then S minus C, we'll call C this distance, which was root 8. And so this works out to be just root 10 plus root 2 minus root 8. Root 10 plus root 2 minus root 8. Now I want you to put all of this in a calculator. Put all of this in a calculator. And you're going to get this is equal to the square root of, putting in all of this in a calculator, root 10 plus root 2. All right, that's 4.576 times root 2 times root 2 times root 10 plus root 2 minus root 8, that's equal to 16. And the square root of 16 is equal to 4. So look at that. The area here is 4. And when we use algebra from C-set maths, the area is 4. Now you didn't have to check it like that. You could have find one of these angles and use area as a half AB sine theta. And once you get the same answer, you know you're right. So the only reason why I did it this method was to check to show you that the integration method is the same. They're both the same. And so therefore we can conclude that the area is indeed correct. So it's good if you remember this formula. If you do mathematics later on in university, sometimes it's good when you know this formula when you're going to be doing like vector calculus and stuff like that. All right. Nice. So now we move on to the next part of the question, which is part B. Part B, it says that we have the gradient of a curve at the point 0, 6 is given by 3x squared plus 8x minus 3. Gradient of the curve, so what they're telling you is dy by dx is equal to 3x squared plus 8x minus 3. That's dy by dx. And they want us to find the equation of the curve. The equation of the curve we're going to have to integrate. So y is equal to the integral of 3x squared plus 8x minus 3. When you integrate this now, when you integrate it, you're going to get y is equal to 3x squared. Add 1 to the power, you get 3x cubed over 3 divided by the power plus add 1 to the power, so you get 8x squared divided by 2 minus 3x plus some constant c. All right, nice. Now after you get a constant c, you're not quite finished just yet. You need to find this constant, but they tell us there's a point on the curve that is 0 minus 6. So they're telling you when x is 0, y is negative 6. Y is equal to negative 6. So when x is 0, y is negative 6. So we can put that in here, that negative 6 is equal to 0 plus 0 plus 0. And so c is negative 6. We don't even need to do nothing more. So the equation of the curve is given by y is equal to 3x cubed over 3 is x cubed plus 8x squared over 2 is 4x squared minus 3x plus c. All right, and that's the equation of the curve. Y is equal to x cubed plus 4x squared minus 3x plus c. So that's part 1. That's the equation of the curve. Nice and easy, soft, a capital T. Nice. Part 2. Part 2 is, we have now, it says find the coordinates and the nature of the stationary point of the curve in BI above. So we need to find the stationary point. So to find the stationary points, we solve dy by dx equals 0. So you can write that down. At stationary point, at start point, dy by dx is equal to 0. And so all we need to do is set dy by dx equal to 0. Set 3x squared plus 8x minus 3. We'll set that equal to 0. We'll set that equal to 0. We're going to just factorize it. So factorizing it, as we can see, we're going to get 3x and x Looks like 3 and 1, 3 and 1. Signs are different. The greater product is positive, so this is plus, and this is minus. And so the two stationary points are occurring when x is equal to 1 over 3 or when x is equal to negative 3. Now, that doesn't give you the stationary coordinate or the point. You just have the x ordinate. To get the stationary points now, you need to plug in 1 over 3 in here to get what is y. So plug 1 over 3 into the equation of y right here. Plugging in 1 over 3 in here. So plugging in 1 over 3, we're going to get 1 over 3 cubed plus 4 times 1 over 3 squared minus 3 times 1 over 3. And remember, c is minus 6, so you can change this, not plus c, put minus 6. Minus 6. And I'm getting, let me see, 27 times 6 plus 14. Let me put that in again. So x cubed, 1 over 3 cubed, plus 4 times 1 over 3 square, minus 3 times 1 over 3 minus 6. I'm getting minus 6 and 14 over 27. So you're getting minus 6 and 14 over 27. That's what I'm getting for y. All right. Now, from here now, we're going to get y is equal to, plugging in minus 3, you're going to get minus 3 cubed plus 4 times minus 3 square minus 3 times minus 3 minus 6, which is 12. So you're getting, this is the point, 12. This is 12. Let me see. This is 12. So the two stationary points are, that looks like 1 over 3. I like to write them in order in terms of the negative coordinate first. So I'm going to write minus 3 over 12, minus 3 over 12, comma, and 1 over 3, minus 6, and 14 over 27. Now we need to determine the nature of each stationary point. So to determine the nature of each stationary point, what we are going to do now is, to determine the nature of each stationary point, what we're going to do is, we're going to find the second derivative. So the second derivative is d2y by dx squared. So d2y by dx squared is going to be equal to, when you differentiate this, you're getting 6x plus 8. That's d2y by dx squared, 6x plus 8. All right. And now you need a second derivative when x is minus 3. So when x is minus 3, when x is equal to minus 3, we're going to get that the second derivative, y double prime, is equal to, plugging in minus 3 here, and you get 6 times minus 3 plus 8. That's negative 10. That's negative 10. Now when x is equal, since it's negative 10, this is less than 0. And so when x is minus 3, that's a maximum point. This is a max point. All right. And then when x is equal to 1 over 3, when you plug 1 over 3 in here, you're going to get that y double prime, which is the second derivative, is equal to positive 10, which is greater than 0. So what does that mean? That is telling us then that this minus 312 is a maximum point. This is a maximum point. And this is the, over here, 1 over 3, this is the minimum point. Minimum point. Generally, the easy way to can tell which one is max and which one is min, which one are going to have the positive y value will be max. and which of the negative y value or the lower y value will be min. So that's that. So we're done. Finally, it says sketch the curve and clearly labeling the stationary points. So I'm gonna sketch the curve now. Sketching the curve. This is the curve now. I'm gonna sketch it. That's the curve. I know it doesn't look that well, but you know, let's work with it. This is how the curve look. We have our maximum point and our minimum point. All right, the maximum point, again, this was minus 312. Let me not make them so close. Let me try to sketch it a little better. Make it a little better. So maximum, then the minimum point. I think this looks better. All right, and the maximum point, this is the point minus 312, minus 312, and this is the point. This is the point, what is this point? 1/3 and negative 6 and 4/27. And then now, once you sketch those points, you can always put in your axis afterwards. So let's put in the axis afterwards. The axis, the x-axis is in between minus 3 and 1/3. So x-axis is somewhere, this is x being 1/3, x being minus 3. X-axis is between here, let me see. Can think of it as closer to 1/3. This is the x-axis somewhere here. And then my y-axis, if this is positive 12, and this is minus 6 and 4/27, it's closer to down here. So this is my y-axis. You want to make it good. Yeah, that's my x. This is my y-axis. This looks not too bad. This don't look too bad. All right. My x-axis, my y-axis. This don't look bad at all. X is 1/3, y. So this is the point where y is negative 6. This is a y-axis intercept. Now we don't know the roots. We really don't know these roots. These are the roots. All right, this is your y-axis. This is your x-axis. And that's it. That concludes this paper. Nice and easy. The only thing you could add to this is to just tell them that your y-axis intercept, you can tell them your y-axis intercept is the point 0, minus 6. You can tell them that the stationary points are minus 312 and 1/3, comma, minus 6 and 14/27. That's all you can tell them. Nice and easy. Soft. So this takes care of 2015 paper 2. I really hope it helped. All the best prepping for your exam. See you soon.